we study the fantastic, the most important one is rearrangement, that is called the McLafferty rearrangement, that is involved in mass spectra. So what is this McLafferty rearrangement? So this is the part a lot of questions are asked from this. If we have a varieties of carbonyl compounds, which kind of carbonyl compounds? Basically what? Carbonyl compounds which type of carbonyl compounds? Having gamma hydrogen atom or having hydrogen in the gamma carbon atom. Then what will happen? You have a carbonyl compound, say it has gamma hydrogen atom. What will happen? It's undergo rearrangement during the mass spectrum analysis involving a 6-member low energy transition state. So in that case, if it has a carbonyl compounds having gamma hydrogen atom, the carbonyl compounds, not the carbonyl compounds, the molecular ion peak from the carbonyl compounds, molecular ion peak from carbonyl compounds, will undergo rearrangement involving or through 6-member low energy, 6-member low energy transition state. What is the beauty of kind of rearrangement? That rearrangement is called McLafferty rearrangement. And what happens in this during such kind of rearrangement? One alkene molecule goes away, one alkene molecule goes away from molecular ion. What is the fantastic things about this rearrangement? This is called McLafferty rearrangement. The rearrangement we see at molecular level on molecules, but this rearrangement happens on molecular ion. So this is called the McLafferty rearrangement, the McLa rearrangement. Let us summarize. So it's for mainly carbonyl compounds. Others compound can happen, but here we are seeing carbonyl compounds. If carbonyl compounds have hydrogen in gamma carbon atom, then the molecular ion peak from that carbonyl compound will undergo rearrangement involving 6-member low energy transition state. One alkene molecule goes away from the molecular ions. We'll see what happens after the rearrangement. And this is very unique. We name the McLafferty rearrangement. Okay, it's a simple latest thing. So C double bond O, this is CH2, this is CH2, CHRH. So alpha, beta, gamma. So here is a gamma hydrogen. Let's say it's Y. So Y is equal to what? Y may be R H OR OH. So this is what the rearrangement on molecular ion. So the molecule upon treatment with high energy electron, it has formed this molecular ion. The rearrangement will undergo will happen on this molecular ion peak. So this is go here, put abstraction, these things, and so what is happening? So we have Y C O H double bond CH2 dot plus CHR double bond CH2. So because of this rearrangement, we'll get the this mass of this fragment. So this will be detected. We'll have m by z value in the spectrum. In the spectrum. We'll take an example. Let's say you have been given this example CH3 C double bond O CH2 CH2 CH3 H. So the question is like that. So what McLafferty rearrangement fragment will we get from this molecular ion peak? So now think it's a molecular ion peak. So rearrangement will happen on this fragment. So these things. So we'll have CH3 COH CH2 CH CH3 double bond CH means propene plus the m by z value for this peak. So let's say the question like that. So the fragmentation is given. So which mass m by z value can be obtained? The question like that. So if you know the McLafferty rearrangement, then only you can come to the conclusion that okay, this m by z peak will come to the here in the spectrum. So that's the beauty of the McLafferty rearrangement. Whatever the rearrangement you have till read today, that happens on neutral molecule upon treatment with some additive rearrangement, some additive or some protons, some bases like that. But here the rearrangement happen on the molecular ion peak. And here the mechanism is not prominent. Why? Because this molecule is highly non-existent. So on its form is rushed toward the detector by 20 microseconds. So there, how can prove your mechanism? So this is this one that is maybe in this kind of way. That's why we are doing this.